So, you've come to learn some stuff before you start your first year calculus class. Just a disclaimer, I don't know everything, so I will not be covering everything that your potential university calculus class will, mainly because every university tends to have a variation in sort of what they teach exactly. It's relatively all the same stuff, but some differences. So I'm just going to do a really general series introducing you to some concepts that are quite difficult when presented initially to many students. So really the goal of this series is to just get your feet wet with many of these concepts. And I've broken it down into like three different topics we'll mainly cover. One is going to be, number one here is going to be pretty big. Two and three will sort of follow. I've put a star at three because I'm not sure if I will do it or not, because in my opinion, I don't think it is as important as number one, but it's good to know it as well, to get introduced to it. So in one, biggest topic we're going to encounter, maybe I should do this in a blue. This will be integration. So you may have heard of this word, or perhaps know what it is. The idea of integration is really one of the fundamental ideas of calculus next to derivatives. So integration is basically the opposite of a derivative. So if you recall back to how derivatives work, where if you were to keep on like differentiating, the exponent on some function gets smaller and smaller and smaller. In integration, it's the other way. It gets bigger and bigger and bigger, just like as a very general sense. And it's basically working backwards. So that's really integration. I'll obviously go much more in depth, and then it's going to be a long chain of videos. I'll have to introduce the topic. I'll have to show you different strategies on solving it. Also, what it really means too. That's important to understand that too, not just know how to do it. So that'll take up most of the time in this series. The second thing I want to do is obviously show the applications. The applications of integration. So perhaps just to like provoke some thinking, volume, for example, is a good area where you would use integration if you want to find the volume of something. For example, stuff like that, or surface area, whatever. It's another tool. You may have seen optimization problems in your high school calculus class using derivatives regarding those topics. Now integration can also be used to that. It'll all obviously make more sense, but this is a pretty important thing to know. If I'm being completely honest, I may not even cover all of 2 and 3. I may just sort of introduce it. And then lastly, not particularly my favorite, but I will try to include it. It's going to be sequences and series. If you hear something very loud on the mic, that is the rain. I apologize for that. I'm too lazy to do a retake, so yeah. All right, sequences and series. So this is like if you have like a bunch of numbers, you want to add them up, or you want to multiply some, add them up, that kind of stuff. Most people would probably teach number 3 before number 1. I don't want to. I said before, I don't think so. It's as important as integration. Integration is like pretty hard. Sequences and series is like nice to know so that you can understand integration. I'll obviously be explaining everything, so it'll all make sense. But that's basically the syllabus of this series, as if I'm some fancy professor. So I really hope I can achieve my goal of just making sure you don't feel intimidated by these concepts. You're more so like, I guess, welcomed by them, and you start to appreciate the beauty in integral calculus. And yeah, I'll see you in the next few videos.